In 2.7, we're going to talk about absolute value functions and graphs. So to start, let's talk about the parent function of an absolute value. The parent function of an absolute value is f of x equals the absolute value of x. One way you could kind of look at this is f of x equals x should be like a straight line going up like this. But absolute values can never cross over in the negatives, so as soon as you almost go negative, it bounces back and stays positive. That's one way you could look at it. Another way to remember is that an absolute value looks like a V. So any absolute value functions we look at should be in a V shape. So combining what we did yesterday, let's take the parent function of an absolute value function and shift it. How we're going to take a look at that is by focusing on the vertex. The vertex is the middle point of our V, and we're going to shift that accordingly to what we see in the function. So in this question, they ask which of the following is the graph of y equals x plus 2, or the absolute value of x plus 2 plus 3. So I see I shifted horizontally and vertically here. The x plus 2, since that plus 2 is within where the x is, that tells me that I'm shifting left 2, and with this plus 3 outside, with the output, that tells me I'm moving up 3. So starting at the origin where my parent function would be, if I shifted left 2 and up 3, I would end up with the graph of D. So tying this all together, let's talk about the general form of an absolute value function. Well, the parent function is y equals the absolute value of x. What we're going to focus on is just the general form. That'll kind of tie in any horizontal or vertical shift, and if this is a stretched or compressed graph. The absolute value general form is y equals a times the absolute value of x minus h plus k. How you want to look at this is the h and k values serve as the values of your vertex, and the stretch or compression is your a value. Another way that you could kind of look at this is your slope. So your a value will tell you your rise over run to start at from your vertex. So let's look at an example problem. We want to graph the function y equals 2 times the absolute value of x minus 3 plus 4. Just looking at that, I can be able to tell what my vertex is and then what my stretch is, or my rise over run. This tells me that my vertex is 3, 4. So before I do anything else, I'm going to plot the coordinate 3, 4. That's going to be the start of my V. So I'm going to go over 3, up 1, 2, 3, 4 right here. So this is the vertex of my graph. From here, that 2 is going to tell me my slope. So from that vertex, I'm going to go up 2 over 1, up 2 over 1. This graph is going to be a V, and it's going to be symmetrical, so I'm going to go up 2 over 1 the other way. And this would be my graph. Another example is the function y equals negative absolute value of x plus 5. Now this might look a little bit weird because there's no number with x. This just tells me it's like x minus 0, or tying in what we did yesterday, that we did not shift this vertically at all. So that means that my vertex is going to be somewhere at 0, and then I want up 5. So my vertex is at 0, 5. And my a value is negative 1. So that means my v is kind of reflected, or it's flipped over. That's going to tell me that I'm going to go down 1 over 1 on each side. And then I'd be done.